Hello, so you want to add some color to your IoT project or maybe just add some RGB lighting effect, but you're not certain how. In this video, I would like to show you how I did it by using ESP32 and ws2812b fully addressable RGB LED. So let's begin. We will use ESP32 microcontroller with integrated Wi-Fi and Bluetooth connectivity. And also, as we already said, we will use this fully addressable RGB LED with possibility to connect multiple LEDs in a sequence in order to have couple of LEDs. So instead of using regular Arduino IDE, I will try to use for this project something, let's say, more professional, and that is platform IO extension for VS Studio Code. So let's check out our setup. Setup is very simple, and I will show you the image right now. So it basically contains of a Node NCU ESP32 development board, and we have a simple RGB LED circle ring which contains 24 LEDs. But because they are connected cascade, basically if we learn to control the first one, we will know how to control everything else. Connection is very simple because let's say it has integrated IC into this RGB LED. We can control all of this with only one data pin, and of course we need power and the ground pins as well. The additional gray wire here is basically the output of our circle RGB, and basically with this we can add even more LEDs to this project. So if we, for example, want to cascade two of these circles, we have that possibility as well. So, as I said, for this project, I was using VS Studio Code with Platform IO extension. So it looks something like this, and here we have our Platform IO extension, of course. In order to get this installed on your computer, you can Google it online, of course, or you can check my other video regarding this topic that is called Start with Platform IO on Linux. Basically, the process is pretty much the same, just the first initial step of getting your VS Studio Code is of course different, but this can be used for Windows as well. Just basically Google and download VS Studio Code, and then just add a Platform IO extension as in this video. So when we have everything like this, we should get something like this here, and we have our project with our main CPP. Of course, now we can compile this and download to our code, but first we need one additional library that is not included by default, and that is fast LED. And in order to get this fast LED, this is a bit different than in Arduino IDE because now you don't have this general search, and you need to find this basically on GitHub, and so basically we need to find this on the GitHub and add the folder to our libs folder, and that's basically it. So let's find it on the GitHub. I will put this link in the comment below, and now we simply need to download this code. There's a couple of ways how can we do this, but I think the simplest way and maybe more effective is to use the option tag and basically to download one of these releases. You would maybe have you would maybe have some additional features if you download, for example, the master branch. But I think the best way to proceed with this is to go to the releases tab and download source code directly from this. Then just extract this source code and place it inside your library file. And now we can basically control our library as the same way as we did in Arduino IDE. So we basically just need to include our library, and then we need to do a couple of things. So because this is let's say more complex project, I will now show you this later, but first I would like to show you how you can simply just control one RGB LED. So let's comment down this, and then let's just uncomment stuff that we should use. So everything is commented, so basically we just need to use these two includes. With this we are including all let's say defined Arduino features. With this we are including all fast LED libraries. Of course, it's I think the best policy to define the pin that we should use for from our node MCU. I will use the pin P0, or in this way we have this enum that is actually GPIO number 0, and this is actually for ESP32. We need to have addition these two defines, and for this example I will say that we have only one LED and save it. With this we are defining actually the ring LED, and basically we are defining the color for each of LEDs that we should use later on. For this, now we don't need everything from here. Now, because I would like to save this, I would just copy setup and loop part. So in setup part, we should add the code that should be run only once, and then dot setup, and then we have our loop. So because this is introduction video, we will do basically everything in setup, and I would just like to add the color, for example blue, onto our first LED, and that can be done very easily. We first need to initialize our LEDs, in this case only one. So we start with fast LED, and we add actually LEDs to this control. We will setting the type of our LEDs. In this case this is ws2812b. We are adding the control pin, sorry, which we defined as P0, and we are selecting actually what the color should we use for our LEDs. And this is the first thing that we need to take care of. As you can see, we are defining here that the first color that we are sending is actually green, then we are sending the bits for red, and then for the blue. So this is a bit, let's say, not a general way, but for this this component is like this. So, and that's only thing that we need to do for the setup. Now, if we would like just to select the data for the one LED, we could simply do something like this. So we need to set ring LEDs of our LED, and because we only have one, we will put here the value of 0. And now this defines which color we should set for LED with this index. In this way, now we can say that we would like to set this to green, because red and blue are defining as 0, and we have some data to the green. So let's try to set first LED to some blue value. So we have here basically intensity. So we are setting the blue color 0 is none, and we have maximum value of 255. So let's put something in the middle. So 138, and that's it. So the main point of this that this will not actually set the values of our RGB LEDs. This will just prepare the data. Fast LED.show is the command that is actually setting this data. So let's save this. For now, we will leave loop open. We will do everything in setup phase. So let's connect our ESP, and let's go to platform IO, and you have your node MCU, and you can click on build. Now, when everything is finished, you can just click on upload. And sometimes when your board doesn't go to the programmator state, you need to reboot it in order to get into correct state. So I was too late now. Let's try it again. And now we are fine. Our code is being downloaded. And now I will put the image on the video because this is static. We have our blue LED light up. Okay, let's now try something maybe more intriguing. So let's check to add some non-standard color. So let's, for example, try this purple one. So just copy the color code and let's paste it here. We have this much. So if you just type in, because this is regex, you can just add the values like this, I think. Now the second tool. And the last. And of course, let's add this as a comment. And let's now build this again. And of course, upload once again. And now we have updated the color, and I will put that image on the screen, so everything is working. Okay, but this is, let's say, just basics, and you would be able to do something like this with a simple RGB, which is not addressable, not smart, with controlling basically 3 pin and setting them to that value. But why is this so more interesting? Because we will actually passing the data for all RGBs, and we have now can have something like this. So if we want to have this RGB, that is first one, actually to the value of this or the color of this violet one, and for example now if we introduce the two more LEDs, and now our LED count is 3, we can do simply like something like this. Just copy this code, change the index, and now we can, for example, put only leave only the red data to this and equal other two to 0. This will make for us some kind of red variant for this. Of course, this should be 2. And let's put the blue one for this. So add 0 to first two values, and yeah. basically, if we just save this now, so we just add two more colors and we increase the LED count. We are using again only one pin for this, and let's now try to build this. And let's now update, reset our board, and as you can see, now we have two more LEDs lit up. So this is basically the power of these fully addressable LEDs. So you can link as many as you want LEDs in a sequence, and you can control each one to the color of your choosing. So if we now remove this and uncomment my example, so this is the example that I created in preparation for this tutorial, and basically what I wanted to do is something like this. So I would like to control full RGB ring, and I would like to set basically three colors, red, green, blue, that are circling around and, let's say, chasing each other. So, of course, what I needed to do, I defined the start of each color, and then we will have some position that will increase when we are running. For this implementation, I do not need a serial, so I will just comment this out. And yeah, basically we are then initializing our LEDs. With this, I'm actually removing everything or setting every LED to 0. Then I'm setting the starts of blue, red, and green to its original color. So blue start will get the blue color, red start will get the red color, and of course green color. So that's basically it. Now I just use this one-liners, so every time I'm clearing our colors and then selecting so that we at each time only have two LEDs lit up. Then I'm showing or applying selected values, and of course here then running circles with when we exceed 22 index, we are returning back to 0. And of course we want to run this in maximum pace because that this circling will not be visible to us, so we have this delay of 50, and now I would like maybe to change this to 30 milliseconds just to speed it up. And now I will again compile this code and upload it so that you can see how easy it is to create something that looks nice. So our compilation is done successfully. Now let's update. Let's reboot our board. Okay, let's try again. And we started downloading our code. And yeah, exactly. If you can see now. So you have something nice as this with only a couple of lines of code. And I think that is the power of these fully addressable RGBs, and And because of that reason, when I designed my custom ESP32 development board, I actually used this fully addressable RGB as its status indicator here. Uh, I didn't see that someone uses something like this, but the way that I can control and basically to select each color by only one pin, I think this is a very nice implementation here with these ICs. And of course, I'm not drawing the power from a GPIO pin from ESP32. Actually, the power is coming from directly from this voltage regulator here. So that's another purpose of this, and I think for some extra cost, this is a very, very good implementation. And yes, I think this is a very easy and good way to add RGB basically to everything, especially to some of your next IoT projects. Or maybe if you want to create, as me, your custom development board using some microcontroller, you can add one signal diode which can have this RGB functionality in order to have, let's say, different states. I think that's very interesting, but what you think about this? If you like this, please like, share, subscribe, and see you in the next one.